Today's topic is tuples. Tuple is the third built-in collection that we have in Python. The first collection we learned was list. The second one we focused on was dictionary, and tuples is another collection. That means it can store multiple values, and we can refer to the tuple by using one name. There are similarities with lists and there are differences with lists. Also, there are similarities and differences with dictionaries. So a tuple can be created by using a name and then using an assignment or equal sign and then a list of values, very similar to lists. However, as you notice, the difference is the parentheses. In lists, we used square bracket and then list of items separated with comma, closing square bracket, and if we want to create a tuple and initialize with some values, then we use parentheses and then list of values that we want to initialize with, separated with comma, and close the parentheses. As in list, tuples also have sequences or order. Tuples are considered ordered. That means they have predefined positions. So the first item, position or index, is 0. Second item's index is 1. Third item's index is 2. We had also indexes in list. We did not have indexes in dictionary. In dictionary, we used keys and values. Keys indicates which item we are referring to. So key is like a name of that position instead of numerical index, and value is the value we store with each key. Here we see only the values. Okay, these are different values and their position is always predefined and known. This is position 0 or index 0, index 1, and index 2. So if we do print this tuple with index 2, that indicates the third item. If we print this tuple with index 0, that indicates the first item. In the second example, y is a tuple with 3 numbers. We can have a mix of numbers and a string. We can have only numbers. We can have only strings. And the second tuple y, again, it is created with 3 items. They are separated with comma and closed with parentheses. If we print the whole tuple, it shows all values. We can apply some functions like max that is applicable in many other cases, not just collection. If we apply this function with a list of a string, then it compares letter by letter starting from the beginning. Uppercase letters have a lower value than lowercase letters. So if you have an uppercase letter and another name starts with the lowercase letter, then uppercase letter 1 would be smaller. So when you do any programming, the key is to practice. You have to do a lot of practice. If you keep writing, you will make mistake and you will learn from there. Okay, so let's create a tuple. Say T1 is our tuple name, and then equal, we use parentheses, right? And then list of values. Let's say I want to use apple and then cherry and then banana, mango. So the tuple T1 has 4 items, 4 strings, and if I do print tuple T1, that will print every value. all of this tuple. If I print one specific index, tuple name, and then in a square bracket comes index. So this indication of index or position format is the same for list, tuple, and dictionary. All of them, when you want to say index, it goes in square bracket. For lists and tuples, you indicate a number. Okay, if 1, that means the second item, so it should print cherry. If it's a list, also we use numbers or indexes, but if it's a dictionary, we use the key here within square bracket. The items have indexes, that means we can say tuples are ordered. Okay, and the apple is first in the order, cherry is second in the order, banana is third in the order. There is a difference with list here. List items are changeable, so I will create a list also. Let's say L1 equal I want to use all these same item, but remember list starts with square bracket. If you don't use square bracket, use the same parenthesis, L1 will become a tuple. Okay, now list, let's say this is list and this is tuple. Okay, so both of them have position or index, okay, predefined, so we need to mention which one position is what. The order we create them, they get the position. The first item we add, that's the position 0 or index 0. A key difference between tuple and list is that the list items are changeable. For example, if I say L1, then I want to change the first item, okay, and change it to orange, okay, and then print the list L1. We'll see that this item will change to orange and then the rest of the items will remain the same. Okay, that means the list is changeable. However, a tuple is not changeable. Okay, once you set it up, once you put the values, you cannot change those values. So let's try. So 0 equal if we try to change the first item from apple to orange for the tuple T1, we will see an error. Okay, so it says tuple object does not support item assignment. That means you cannot assign a value to tuple items. In other words, tuple items are not changeable. As a result, you remember we could add or append L1 dot append new item. Let's say strawberry. The first item will change to orange, and then second, third, fourth, and it will add strawberry. Okay, with the list. We have seen that here it's not changeable, so I'll turn off this code. How about append? T1 dot append. Can we do that? We just saw that tuples are not changeable. That means once you set it up, you cannot change the values. As we know, tuples are not changeable. It should also throw an error. If I turn this one off first, then we'll see that we'll be able to append more items with list. and that's why you see strawberry was added at the end. Okay, now try to add strawberry with tuple with append, again error. So we cannot change an item, we cannot append an item with tuple. Okay, we can find the length of a tuple. So I'm going to remove this code, also remove this code. Currently we have 1, 2, 3, 4 items, and if I want to find the number of items, I can use the function len. Len will give you the length of list or tuple, so it will say how many items. Okay, I'm printing how many items, length of t1. I'm not printing t1, I'm printing length of t1, and length of t1 is 4. 1, 2, 3, 4. Let's take a look at the slides. Tuples are immutable, that means cannot alter, okay, cannot change, similar to a string. You cannot change a character from a string. ABC is the string, the y variable is initialized with ABC, and it's a string. And if I try to change the third item is y2, right? Then it shows an error. However, in a list, we can change the third item. We cannot change the items in tuples as well. It throws error. Okay, we can read or print any positional item. For example, I can of course print the third item, but I cannot change the third item. In other words, it's immutable, okay, or unchangeable. Okay, since tuples are fixed, you cannot make changes in tuples, so you cannot apply the functions that we could apply on lists. For example, we could sort list by using listName.sort function. That can be used in list, but tuples are not changeable, so we cannot sort a tuple. So I will sort, so L1 dot sort function. Okay, so that will make the list alphabetical order. That means banana will come first, then cherry, and so on. So it did sort banana, cherry, mango, orange, and strawberry, see alphabetical order. If I try to sort tuple, t1 dot sort, it's gonna throw an error in here. See, there's an error. Tuple object has no attribute sort. Similarly, we cannot apply some other functions that we use with list. For example, append adds item at the end of the list, but we cannot apply append on tuple. We cannot do reverse that we can do on the list. Sort it and then L1 dot reverse. Okay, and then let's see. I have to remove this sort from the tuple. And then when I said reverse, what it did is it sorted alphabetically. Banana was first, cherry was second, and then when I said reverse, it just reversed the order. The first item went to the last item came to the first, and every other item changed their position. So last item came first, second last came second, and so on. So that reverse, okay, we can use it with list. We cannot use this type of function with tuple. So sort is like changing items, right? Moving items from one position to another. Append is like adding more item. Once you make a tuple, you cannot make changes. That's why you cannot sort, you cannot append, you cannot reverse. All of them need changes in the tuple. So we cannot do that with tuples. Let's take a look at what we can do with tuple. Here, tuple, you can use two functions. One is count and the other one is index. This count function will tell you how many times a value appears in the tuple. Okay, that's count. And index function will give you the position of the value. Okay, so let's try tuple here. I'm going to use this one, and then I can add duplicate values. Okay, so I can have another okay, both in list as well as in tuple we can have duplicate values. So at 0 position there is apple, and then 1, 2, 3, 4th position is another apple. Now if I use the function count, t1 dot count, and tell what I want to count, I want to count apple. Okay, that will return how many times the apple appeared in the tuple. So I want to print this, how many times it appeared. So that will give the number of times the item apple is in the tuple. Okay, so if I run, you can see that apple appeared 2 times. Here is 1 time, here is another time. Length has changed to 5. 1, 2, 3, 4, 5. So current length is 5. That's why I'm saying 5. Okay, so I can say length and then comma len. If I use count function for something that does not exist, okay, if it does not exist, that means count should be 0. We have strawberry, let's say strawberry. I want to find strawberry appeared how many times in the tuple. So if I run, it shows 0 times. That means it does not exist in the tuple t1. Okay, so there is a count function. There is another function we can use with tuple, that is index. Index will say where the value that we are passing to the function appears in the tuple. So I will use the function index. Okay, if a strawberry is in the tuple, then it will say at which index it is. Remember, index can be 0. So if it does not exist, okay, what index makes sense? If I say apple, index would be 0, right? If I run, index is 0. Let's say index of apple, or the item apple, appears at 0 position. So if you have multiple occurrences, it looks for the first occurrence. Okay, it finds the first occurrence when you use the index function. So the first occurrence is at position 0, right? So if I run, it shows index 0. Apple is at index 0. Now, if I use something that does not exist, what would be the result here? Let's say if I say strawberry, strawberry does not exist in the tuple. So t1.index strawberry, what will it return? Since 0 means the first position, so index 0 will not make sense, right? If it does not exist, And if it does exist, it can be anywhere at 0 and after. It can be 0, it can be 1, it can be 2, any positive number it can be if it does exist. So if it does not exist, let's see, the index method raises error if the value is not found. So you can use the try block we have seen previously. If it does not exist, it throws an error. Tuple and list, they can represent negative index. The last item's negative index is -1. The second last item, negative index is -2. So negative index starts from the last item and starts from -1. So if I print T1 and position is -1, okay, so that will indicate the last item of the tuple. Both of them are apple, so it's confusing. I'm going to remove this one. We don't know which one it did print. Now if I remove this one, the last one would be mango. So I run, and then it did print mango. So that has a negative index. If I want -2, that will represent banana. Also same in list. It has negative index. The last item is -1, -2, -3, -4. That's how you go from last to first, okay, with a negative index. Okay. So two functions can be used. These two functions are function specific to tuples. Okay, there are other functions that are not specific to collection, for example, mean or max. And in list, we can append, we can count, like this one, we can count, we can extend, we can do index or find index of an item, we can insert new item, we can remove an item, pop and remove, they both do the same thing. We can reverse, so that will bring the first item to the last and second item to second last, and so on. We can do sort, that will put the items in alphabetical order or numerical order from smallest to largest. We can do also sort, but reverse order, that will sort from largest to smallest. But in tuples, we cannot use any of those that changes the items. For example, append, add more item. Count does not change anything. Extend, change the tuple itself. Index does not change anything. It gives the position of an item. Insert changes something. So we cannot apply insert in tuple. Pop, remove something. We cannot apply. Remove something. We cannot apply in tuple. Reverse also changes the objects from one position to another. So that's not allowed in tuple. Sort, not allowed in tuple. Okay. Now, as Python does not have a built-in tuple structure that can be modified, so when you need modification, you need a lot more functionalities to be able to modify. So list functionalities or the structure is much more complex as compared to tuples. Okay, tuples are simple. You cannot do a lot of things, but it's simple. Thus, for the same number of items, you will have a better performance for tuples than list. If you look at on the left side of this assignment, this is a parenthesis and then two items separated with comma. So this left side is a tuple and right side is also a tuple. Okay, we can assign a tuple to another tuple, but left side one should be some variable name, not values. Okay, so if I want to use this in our code, I'm creating a tuple, so brackets, and then if the tuple has two values, then I will use two variables, okay, A and B. Equal, I can put another tuple in here. So tuple with two values, 34 and 55. Now, when we have this kind of assignment, right side values get assigned to the left side variables. So if I print A, for example, if I print A, this A is a string, as I put in quotation mark, and this A is this A variable. Okay, so I'm going to remove this list. A is expected to have this value. Okay, this A is the string A. I can put anything in there, doesn't matter, but I want to say the value of A is A. That's why I'm going to say A. Okay, now also I can print B, and the variable B will be 55. Okay, so when you have tuples on the left side of equal sign and another tuple on the right side of equal sign, we have variable on the left side not constant, then those variables take the values from the right side. Now if I do put here something like this, for B equal this is not going to take this value. 4 is 4. You cannot change 4. It's the constant. You cannot change it. That's why it's showing an error. Okay, so the left side need to be some variables. All right. Now, if you compare tuples and dictionaries, we have seen that there are differences. When we create a dictionary, we use curly bracket instead of parentheses. Okay, dictionary we use curly bracket, but dictionary also each item has a name or key. In dictionary, for example, D1 equal, we use curly bracket and then a key, say key1, and then a value with the colon in between. So the value that can be apple, one item, and then second item K2 colon, and then value is cherry. Okay, so the D1 is a dictionary with two items. The key is K1 and K2, and the values are apple and cherry. Right? So if we look at the differences, we use parentheses here, we use curly bracket. We have key and value, we have only values. Then how about the key? Key is predefined or known. It's a position wise. 0, position or index, this is 1, this is 2. Here we have to define what key we want to use. Okay, so there are similarities and differences. Similarities is that both of them are collection. One is ordered, this one ordered, that means the first item in index is 0, and this dictionary, it doesn't matter, I can say K2 first and then K1 next. It will not make any difference, their position. Okay, they're known by the tag or key. These items can be found out by tag or key. In tuples or list, you can have the same value more than once. So I can have apple. But in dictionary, You cannot have the same key more than once. Okay, K2 and colon, let's say orange. Okay, when you try to do that, look, I have used double quote, I have used double quote, I have used colon, also double quote. But since K2 is already there, I cannot use K2 again. Okay, so the same key is not allowed in dictionary. Here also the same key is not allowed, and those keys are already predefined 0, 1, 2, 3, 4. You cannot change it. And technically, a same key you're not using in list or in tuple. Here, since we can type what we want, but if we use the same key, it will not take. Okay, I can remove this, but how about I create, not at the initialization time, but if I create the same key, okay, D1, and then the key is K2 equal mango. Can I do that? Yes, I can do that. Now, when I say K2 is mango, it's going to look for the key. If it does already exist, it will change that value. Okay, so K2, this K2 cherry will change to mango. If I print D1, it's going to print mango and apple. Cherry is gone. Okay, so I said find the item whose name is K2 and change it to mango. So it did change it here. But we can have duplicate items in tuples or in lists. Okay, though these are values, not really the key. The keys are indexes here. The positions are indexes, or you can say this is the index here. Okay, indexes are not numerical. Indexes are string. They have name. Now here D is a dictionary, and then if you use a key such as this one that does not exist in the dictionary, as this is an empty dictionary, so when it executes this line, the dictionary is empty. So it creates a key CSEV and a value 2. Again, another line. This is the index or key. Since it does not exist in the dictionary, only this one exists so far. This does not exist, so it's going to create a new key and value pair. Now we have a dictionary which looks like something like this after creation or after executing these lines. Now we have something like this: CSEV colon 2 and CWEN colon 4. This is how the dictionary looks like after executing these two statements. Now, each of these items can be treated as tuples. Okay, so we have one item. This can be a tuple. This can be another tuple. And remember, we did assign tuple to tuple. Here, xy equals some value. These need to be variable. Similarly, when we say for two variables in the dictionary.items, dictionary.items will return this first item, okay, as a tuple, and when it executes this loop second time, it's gonna dictionary.items will return this second item as tuple. Okay, so let's try for, since there are two things, one is key and there is value, So we need to use like two variables a, b, okay, in the dictionary d1 dot item, okay, and then we can use those variables to get the values. d1 dot items will return each of these values, okay, after we change the first k2 to mango. The dictionary has mango and apple, okay, like this one. Now we are traversing through items, so there is no first or second. It will pick up an item, and it's k2 and mango. k2 is the key, mango is the value, and that goes in a and b. So if I print a, okay, comma, let's say I'm going to put a space and then b, so that will print the key and the value. Okay, I need to probably restart. So the changes that we made is gone. So there is for a b in dictionary 1 dot items, okay, and then print say a space b. So I don't need to print this, and then run. I did take k2 mango, k2 and mango, k1 and apple in two different variables. Okay, so dictionary items are essentially treated as tuple. Okay, each item is a tuple with two values. If I print directly d.items or d1.items, then it will show d1.items function, okay, and then print individually, and let's see now items. You see this is like a tuple with two items only. You see the parenthesis started here, parenthesis ended here, one item comma another item, and again another tuple here, started with parenthesis opening and closing, and then we have one item in the tuple and another item in the tuple. So dictionary.items breaks down each of these items into tuples. Alright. Now we can compare tuples. If we do compare tuples, we can compare like greater than, less than, or equality. So that comparison will give you result either true or false. Okay, so that's a Boolean comparison. Boolean comparison either say whether this is true or false. If I compare two tuples, I will remove the dictionary, and then let's say okay, if I'm comparing two tuples, the first tuple is 3 and 7 9 2 is less than another tuple is say 4 2 8 1. When we make this kind of comparison, it compares one item by one item. As soon as a comparison result is found by any of the items, it stops comparing. If some of the items are matching, it goes to the next item, okay, if they matches. So when we compare this, we are essentially saying is 3 less than 4, which is true, right? You can say print true. If not, print false. Okay, this tuple has no function here, so you're comparing two tuples. Compare one item by one item. So the expected result is true because 3 is less than 4. Now if I make the first item the same as the first item of the other one, then it will compare the first with first, and when it finds the same, it goes to the next item. So it will compare 7 with 2. Is 7 less than 2? No. So it's expected to tell false. Okay. Alright. Similarly, when we have list of strings, we can make same comparison. Now when we have list of string, it compares first one with first one. Here we have Jones and Jones, so the first one is the same. If it compares Sally with Sam, the first letter is capital S, also capital S. So it goes to the next letter, A, and they're the same. Then it goes to the next letter, L, M. L is smaller than M. L comes before M in alphabet order. J, K, L, M, N, O, P, right? So L is smaller. So you will keep comparing, and then we get result which one is smaller. If this one is smaller, we'll say true. And according to our values, John shows the same, Sally and Sam, first two letters are the same, L is smaller than M. So overall, this tuple is smaller than this tuple. So the expected result will be true. If I change, let's say, lowercase j, now it's going to compare lowercase j's numerical equivalent with uppercase j's numerical equivalent. Uppercase j has a lower value. Uppercase A starts with 65, lowercase a starts at 97, so that's numerical equivalent. So all uppercase are smaller than any lowercase. So this has a larger value, j has a larger value, lowercase j has a larger value than uppercase j. So this is not true, it should say false. So the expected result, after I change this, expected result is false. And you know why? Because of this j and j comparison. Okay, we have seen dictionary and dictionary items. We saw that we have only two functions for tuples, and if we have a tuple, then can we use some other technique to do those operations such as sort, append, and so on. In this example, the dictionary is converted to tuples, okay, by using items, and then we use sorted, a function on dictionary.items. That means we are applying a sort on these tuples. As you can see that the bracket says it's a tuple, it's not a dictionary. Another tuple. Okay, now we cannot apply the sort function on a tuple, but we can get a list of tuples, okay, a list of tuples, and then sort them. The sorted function, if we pass these items, they get sorted. A, B, and C A is smaller as compared to B and C, so this item comes first. Okay, here in this example we have a dictionary and then extracted the items, so that gives you different tuples, and then applied sorted function, so that will sort different tuples and then create the tuple T. Okay, so when you print T, you see those tuple items. Now we can apply this T that we extracted, and each of these items have two values, so we need two variables that we can use to represent each of these values. Now if we want to sort on items, again we cannot sort the tuple, but we can extract items and then we can use the sorted function. Now here, look at this example. C is the curly bracket indicates it's a dictionary. Also this colon and key and value. And then we create an empty list, TMP. Now we're picking up two variables and picking up every item from this dictionary. Okay, when it picks up the first item, the k variable will take a value and b variable will take 10 value. And then we created a separate list and then added this key and value in the list. So now we have a list. It contains values and keys. Okay, when we added them first value and then key, because we want to sort by values, not by key. So when we print this list TMP, it shows a list of tuples. The first tuple, second tuple, and third tuple. List of tuples. Okay, and it did a sorting on the list. See, TMP is the list, and then sorted on the list in reverse order. Highest value is 22 and C. As is compared from the left side, so it will compare this item first with this item and this item. And when it's sorted based on the item that came from the value, okay, originally, but we made it as the first item in the list of tuples, so that when we compare, we can compare the values instead of key. So sorted on values. Okay, here is the whole algorithm, and there is a shorter version of the lines of codes. We're going to talk about the shorter version in another class. Okay, we have done a traversal of tuples, such as this one for, let's say, for A in T1. Okay, and then print A. That will pick up every single item from the tuple. And okay, I'll copy this, go to a new tab. Okay, so let's open, and now we have each of these items. Okay, the for loop. Also we could use index of T1, for example, T1 with index as a variable. In that case, we need to make this as index. Let's say we can say range. How many items? 5. So range 5. Range 5 will take different values 0 to 4. That means T10, T11, T12 that we print. We get the same result. Okay, and we can also create a tuple from two tuples. For example, let's say T2 equal, let's make a tuple 1, 2, 3, 4, 5, 6, 7, it doesn't matter how many. Now we can create another tuple. We're not changing T1 or T2, it's fixed, but we can create a new tuple T3 equal T1 plus T2. Okay, and then print T3. We'll see a combined tuple from T1 and T2. Okay, let's run. See that it became one tuple as a combination of both, and we could combine by using a plus sign. We can also multiply with 2. If I do multiply with 2, so T3, I'm printing T3 multiplied by 2, and you see that same tuple appeared twice, equal to 7, again equal to 7. There are some techniques that we can use. Even though tuples are not changeable, we can always create a new tuple. Okay, so let's say we have this tuple with 3 values, and then I can make a list from the tuple. Okay, so list from tuple T1. So all of these items will be picked up, and Y will become a list. T1 is a tuple, but Y is a list which has the exact same copy or exact same items. Now, since list is changeable, I can change, let's say, second item, okay, to say QE. Now here change the third item here. This is the third item. So banana of the list, not the tuple, banana of the list has changed to QA. Now I can create a tuple from the list. So let's say T2 equal tuple from the list Y. So, and then if I print T2, I will see apple, cherry, and kiwi. So it's just some technique going back and forth between tuples and lists. Okay, similarly we can append in the list and then get the tuple from the list. Once we have the tuple, we cannot change the tuple. Okay, but we can change the list. So we can create list, make changes that we can apply on the list, and then put back in a tuple. Okay, these are some of the techniques we can use, and that's all for today. Okay, so I'm gonna finish this session here and see you next time.